Hello students, welcome to my class. In our earlier classes, we have already discussed about some concepts on force. Today, we are going to discuss about center of gravity. So, let us start the class. Students, we know about the difference between mass and weight. What is mass? It is the amount of matter contained in a body. And what is weight? It is the gravitational pull applied by the earth on an object. Okay, and this force is called force of gravity. And if we consider that the body is made up of tiny particles of weight, suppose W1, W2, W3 and so on, then the total weight of the body would be the sum of all these weights. Okay, as you can see in this diagram, the weights are parallel to each other and they are acting downwards because the gravitational force tries to pull the body towards itself. So the force is applied downwards and they are parallel to each other. So the weight would be the sum of weights at different points, isn't it? So what about center of gravity? Center of gravity is considered as a point on the body about which the algebraic sum of moments of force acting at each point is 0 and it is denoted by G. Center of gravity. Okay, and you need to understand that center of gravity doesn't mean the center of the body. It is a point on the body about which all the moments of force acting at different points will give us the algebraic sum of 0. In other words, we can say that a body is nothing but a point particle of weight W which is placed at its center of gravity G. Okay? Hope you understand. From our discussion, we can conclude that the center of gravity Cg of a body is the point about which the algebraic sum of moments of weights of all the particles constituting the body is 0. Okay? And the entire weight of the body can be considered to act at this point howsoever the body is placed. That means the body can be placed in any manner, but the center of gravity of that body remains the same. Okay? Students, let us now discuss some important points related to center of gravity. The first point is that the center of gravity of a body, it depends on the shape of the body. That means if we change the shape of the body, then the position of center of gravity also changes. For example, the center of gravity of a straight wire or straight rod is at the center of its length. But when we deform it or we change the shape into a circle using that particular wire or rod, then the center of gravity lies at the center of that particular circle. The next point is, it is not necessary that the center of gravity has to lie on the body. What does it mean? Let us take an example. See, if we take a ring, okay, the center of gravity of that particular ring lies at the center. Now, it is clear that at the center there is no material available because it is a vacant space. Still, the center of gravity lies at the center. It doesn't lie on the body. That means it doesn't lie on the material that is used. It doesn't lie on the body. Okay. The next point is the weight of the body can be considered as the weight of a point particle that is kept at the center of gravity. Okay. Hope you understand. Students, let us now discuss about center of gravity and the balance point. Okay. Balance point. That means a point at which we can keep the body balanced or we can balance the body. Okay. And that is the center of gravity. For example, if we consider the meter ruler, it is of 100 centimeter. The center of gravity lies at the midpoint, that is 50 centimeter mark. And we can balance the meter ruler at the 50 centimeter mark even if with the edge of a knife or our fingertip. Okay, I don't have a meter ruler with me, but what I have is a scale that we use in general. So this is of 30 centimeter. So where should the center of gravity be? It should be at the mark of 15 centimeter because it is the midpoint. So let us see if I can balance the scale at the 15 centimeter mark. As you can see, you can do it by yourself as well. Okay, so I am going to balance the scale at 15 centimeter mark by keeping it on my finger. Okay, so I am just trying to balance it now. See, if I keep it behind 15 centimeter, that means at about 14 centimeter, I cannot balance. If I bring my finger away from 15 centimeter or ahead of 15 centimeter at about 16 or 17, I can balance. But when I keep my finger at exact 15 centimeter mark, then you all can see that I can balance the scale. Scale is oscillating a little bit. Now it will come to rest after some time. Now you can observe that the scale has come to rest and it is balanced. From this, you can clearly understand that we can balance any object at its center of gravity. Same way, let us see how we can balance a circular object. I have a circular paper plate. You might have seen at your home or at some parties as well. Okay, so where can I balance this? As we have already discussed, the circle has the balance point or the center of gravity at its center. So see, if I put a pen over here and try to balance, I can balance. But when I try to keep the pen at the center, you can clearly see that I have balanced this paper plate which is circular in shape. In the same way, if we need to balance a square sheet or lamina, then you can balance it at the intersection point of their diagonals, which is nothing but the center of gravity. You can balance that sheet or lamina with the help of a pin as well. Okay, so from this discussion we can come to a conclusion that we can balance an object at its center of gravity. So what about a body having non-uniform shape? So let us try to understand this concept and find out where does the center of gravity lie in case of irregular shapes. Okay, students, let us now try to find out the center of gravity of this irregular lamina. Okay, so as you can see, there is an irregular lamina A and we need to create 3 holes at 3 different points of the lamina. Suppose those are A, B and C. Now what we need to do, we need to suspend a plumb line through the point A which is attached to a retort stand with the help of a pin. What is a plumb line? Plumb line is a line that is attached to a heavy ball of any material at its end. Okay, and it is used to find the vertical line. You might have seen it at the construction site of a building. Okay, and just have a look at this picture. This is nothing but a plumb line. Okay, so it is used to find the vertical line. The lamina A needs to be free to move. That means it should be attached to the retort stand in such a way that it can oscillate. When the oscillation stops, you need to draw the straight line along the plumb line. Okay, just like this. See, this is the vertical line drawn from point A. Suppose it intersects the lamina at D. Okay, in the same way we can find the vertical line from point B and C. So we need to repeat these procedures. Okay, so we get the vertical lines like this. Okay, so suppose this point is E and this point is F. Now you can clearly observe that all these vertical lines, they intersect at a point. Suppose this is the point O and O is nothing but the center of gravity, that is denoted by G. So by following this process, we can find the center of gravity of a body of irregular shape. Okay. One more thing that is to be noted, that for stable equilibrium, the center of gravity should lie as low as possible. That means it should lie just above the base and near to the geometrical center of the body. Okay. Hope you understand. Students, today we have discussed about center of gravity and how to find out the center of gravity of an irregular lamina. Hope you have understood everything clearly. If not, please watch the video again, go through the book, and I hope you would understand everything clearly. You need to revise again and again for a better understanding. So, as I always say, keep revising, keep practicing, and most importantly, keep smiling.